analysis challenge for basic calculus. The problem we will be working on focuses on finding the derivative of the function f of x equals the quantity of x squared plus 2x raised to 5. An incorrect solution for this derivative was given as f prime of x equals 5 of the quantity x squared plus 2x raised to 4. Our goal here is to examine this solution, find where it went wrong, correct it, and explain why a final answer makes sense. Let's start by identifying why the given solution was incorrect. First, recognize that f of x of the quantity x squared plus 2x raised to 5 is a composite function. It has two parts. The inner function, g of x equals x squared plus 2x, while the outer function, f of x equals x raised to 5, where x replaces the inner function. The solver only applied the power rule to the outer function, resulting in 5 of the quantity x squared plus 2x raised to 4. However, in differentiating composite function, we cannot stop there. The mistake is that the solver did not multiply the derivative by the inner function. This step is non-negotiable for composite function, so this solution was incomplete and wrong. The correct rule to use here is the chain rule. The chain rule is specifically designed for differentiating composite functions of the form f of x equals f of g of x. It states that f prime of x equals f prime of g of x times g prime of x. In simpler terms, take the derivative of the outer function, then multiply by the derivative of the inner function itself. In function structure just like our problem, the chain rule combines with the power rule to give f prime of x equals n g of x raised to n minus 1 times g prime of x. Let's compute the derivative correctly step by step. Step 1. Define the inner and outer functions. The inner function, g of x equals x squared plus 2x, while the outer function, f of x equals x raised to 5, where x equals g of x. Step 2. Differentiate the outer function with respect to x. So, using the power rule, f prime of x equals d over dx, x raised to 5 equals 5x raised to 4. Substitute back x equals x squared plus 2x. Thus, f prime of g of x equals 5 of the quantity x squared plus 2x raised to 4. Step 3. Differentiate the inner function with respect to x. Using sum rule and power rule, g prime of x equals d over dx, x squared plus d over dx 2x equals 2x plus 2. Step 4. Apply the chain rule. Multiply f prime of g of x times g prime of x. Thus, f prime of x equals f prime of g of x times g prime of x equals 5 of the quantity x squared plus 2x raised to 4 times the quantity 2x plus 2. So, our final correct derivative is f prime of x equals 5 of the quantity x squared plus 2x raised to 4 times the quantity 2x plus 2. So, let's confirm why this answer is valid. Composite functions change based on both their inner and outer parts. So, if we only take the outer function's derivative, we ignore how the inner function x squared plus 2x affect the overall rate of change. Multiplying g prime of x accounts for this relationship. And this is the end of our discussion. Thank you so much for watching.